Yes, Deepika. Hi. How are you?
Hi, I'm doing good. How are you?
I'm doing great. Thanks for asking. So if you can just increase your microphone volume, I mean the speaker volume. I'm
I think it's the maximum value. Uh,
okay. Okay. Let me increase it from my side then. Okay.
sure.
Yeah, this looks good. Okay. So let me start sharing my screen, and in the meantime, if you can just quickly introduce yourself. So where are you from? And
I'm from Hyderabad itself, so I would like to start my career now. So I took a break for almost 5 years.
mhm.
So I was working in software testing as a automation test engineer, but I would like to shift my career into the development side. So
Okay. Okay.
that's why I'm taking it.
Nice. Nice.
Other
So any
course.
particular reason like behind selecting big data as your next career opportunity? Is it just going with market, or you have got some references? Yeah.
Now the market is having opportunities in big data, right? So I would like to take this one. So initially I was thinking to take .NET
Mm.
training, but most of them suggested to take big data. So
Okay.
that's
Okay.
why I said.
Any great. So any knowledge in the generic tools, SQL, Java, or any of this stuff, Unix or any of the basic stuff?
I have few basic skills on SQL queries and a little bit knowledge on Java.
Okay.
I did my Java and Java course during my engineering, but now I forgot everything.
No problem. That should be fine. Okay. Okay. So we have a lot of time to discuss on that. Okay. So let me quickly go ahead with the topic. Okay. So before getting into Hadoop, what is Hadoop and what all it can do, we'll just have an introduction to big data. Okay. So you know Hadoop is part of the big data technology, right?
Can you
So
speak a little loud, please?
yes, yes, that's the problem. I see there is a lot of, I mean to say, like I can hardly hear you. So is it audible now? Am I audible now? I'm just coming close to the microphone. Yep.
Yeah, now it's good. Little okay. Yeah.
Is it good or okay, or should I
Yeah,
increase the
it's
volume yet more?
good.
Okay.
Mm.
Okay. Yes, as you know, this Hadoop is a big data technology. So let's focus some light on what is big data, what are its characteristics, where does it come from, and what is the core concept of your big data stuff. Okay. So do you know anything about big data? See, the first thing that strikes your mind when you hear a term called as big data, the basic thing, like big data. So what is the first thing that strikes your mind? Just call it out of everything technical stuff. Just an English meaning of your big data.
Big data means it's a large data.
Right.
Yeah.
Right. So something which is to deal with the large amounts of data sets, right? So you can see, you can take any industry, you can take any kind of an application. So the data size will keep on growing. For example, you take an application A. So the amount of data it is generating today is definitely less compared to the amount of data that is expected to generate tomorrow, right? So every day by day, the data keeps on increasing but doesn't decrease, right? So new applications, new users, or take it Facebook. So new logins have been introduced, new people are getting introduced to the Facebook, Twitter, or all this stuff. Okay, so day by day the data size is going to increase drastically. Okay, so we already have some tools. Whatever the tools we have, SQL, Oracle, MySQL, PL/SQL, Teradata, right? So all these are tools which we are currently using in the market, right? Which we are currently using for our organization. So these tools are restricting themselves to some extent. I mean to say, like, for example, if the data size is within the range of some 15 GB or some 100 GB or some 200 GB, my tools can process it. But if it is beyond that range, my tools will not be able to process or will not be able to capture it, right? So all in all, big data is said to be the size of the data when it becomes beyond the capability of your existing software tools. You call it as a big data. Okay, so whenever the size of the data increases, whenever the size of the data reaches beyond the capability of your existing tools, you call it as your big data. Live with this? Hello. Yes,
Yeah,
Deepika.
yeah.
You
Can you explain it a little slow because I'm the beginner of this big data. I don't know anything about that.
okay?
So yeah, that's why.
Okay, so let's get into details of this. So you must be hearing all these technologies. You know, PL SQL, you know, MySQL. Have you heard about these Oracle, Teradata? Right. So these are some of the data processing tools. Okay.
Oh,
So for example, you have got some data. For example, you have been a Java developer, first suppose. Okay. The data would be there in the backend. Okay. So all the data would be there in the backend. They will be there in the database. Like for example, you take it on Oracle database or MySQL database or Teradata database, anything. Okay. DB2. So all these are the databases which are actually storing the data and which are actually processing it. Processing as in anything. For example, you have a table.
mhm.
You've got some knowledge on the tables and all the rows and column stuff,
Yeah.
right? Say for suppose
In
you have a
general,
table,
I have a little knowledge on the
right? So you
tables.
have a table with suppose 3 columns and say suppose 10 rows, okay? Starting with ID equals to 1 to 10, okay? ID, name and salary are the 3 columns, and I have records starting from ID equals to 1 to ID equals to 10. So these are the 10 records I have with some name and with some salary, okay? So for example, I want you to get only the IDs which are greater than 5. What do? You just write a query, right? So what is a basic query? Select star from so and so table where ID is equals to greater than 5,
Mhm.
right? So out of a given database, out of a given data, you're just pulling based on your requirement. Right? Your requirement is to get the details which are greater than 5. Okay, so you have written a query for that. So that's just a kind of a process. It's kind of a processing of a data. Okay, you have some requirements using which you using some kind of queries or using some kind of commands. You're actually processing some queries on the data. So you call that as a processing. Okay.
Mhm.
So all this kind of process will only work for my existing tools if the data size is within the range, within some kind of a range. But if the data size keeps on increasing, for example, I have a table which is of size of some 100 GB, I'm okay with it. If it is some 1000 GB, my tool may not be able to process it, right? So it's beyond the capability, it's beyond the limit of my existing tool. Okay, so that's where you call it as a big data. That is large data. Okay, so when the data size is large, simply it's called as a big data.
Okay.
Okay, so if you can just come to the units of it, I'll just show you the units because this is just a definition of your big data stuff, and these are the units. So you've been hearing about bytes, kilobytes, megabytes, gigabytes, like MBs, GBs, and TBs, right? So as of now, we are currently dealing with petabytes of data.
Mhm.
Okay, the terabytes is already gone. We have been dealing with petabytes of data. Okay, so and very soon it is expected to come to exabytes even. Okay, so that's
Okay.
what the general expectation is. So it keeps on increasing. It keeps on increasing. The data is generating. We'll see from where is it generating. Okay, we'll see in the sources from where the data is getting generated. And these are the units of your data which are currently being used, the petabytes, and it's going to
Shravan,
be
excuse me.
yes.
I'm not able to hear your voice actually. It's breaking.
Is it? I'm really sorry for that, but let me just adjust this. Jilani, you're there on the call. Hello.
Yes, yes, Shravan.
Jilani, you can hear my voice. I mean, do you have any problem with my
No, no.
voice? Is it
Sometimes
audible?
your voice is low. It's audible, not breaking, but sometimes it's going low.
Is it? Okay.
Yeah, that's it.
There must
Are
be
you
some
using
network.
headphones or directly speaking on your laptop?
I'm directly speaking on my laptop because headphones will give me a lot of disturbance kind of a thing.
Oh, okay, okay. Okay, carry on.
If
Okay,
required, I can use. I can use. That's not a problem.
okay, okay. Proceed.
You want me to give a try on that?
Yeah, like if you have headphones, please give a trial, or else you can
I
proceed.
I have it. Let me just try it then. Mhm.
Kevin, I think it's better to remove the headphones. Your voice is too low. It was little high when you are talking directly.
Okay. Okay.
Yeah, it's
So
better
let me
now. You can proceed.
forward. Okay. Am I audible now? Now?
Yeah, now it's better.
Okay. Sorry for that, Deepika. Yeah. So yeah, we've been talking about the sources. I mean the sources of our data. Like we have been talking about data size is increasing, data is growing, and data is generating at a faster rate. But where is this coming from? Okay, that's the first question we get, right? So where is this all data coming from? We'll see the sources in quick. Yeah. So these are the sources which have been segregated into three. One is the mission, human, and business process. Okay. So if you come to the mission generated data, you can take the satellite images, or sensors, or video recordings, or bioinformatics. So you know what are these video recordings and audio recordings, right? So for example, you are working for some organization. You have the CC cameras there, right? So whatever the data that gets generated from that will be a video recording data. It can be a video. It's example. So the number of emails you are sending now is definitely more than the number of emails you have sent around 10 years back. Is it okay? Is that right? Because we've got some kind of an awareness. So you start working for some organization, you transact everything using an email, via an email, right? So the number of emails you send every day, the number of emails you send or receive every day will definitely increase. Getting my point, Deepika?
Yes.
Right? So this is one kind of an example. So the number of emails we are sending is increasing, and the amount of activity you do on social media is also increasing. Say for suppose 10 years back, we don't even have access to Facebook. We don't even have access to some kind of a Twitter. Okay, so these all have been introduced newly. Take it YouTube, take it Twitter, take it Facebook. So nowadays we do a lot of activity on Facebook. Say for suppose you log into Facebook, you comment on something, you post something, you like or you share. So every activity will in turn return some data. Okay? Every activity you do on the web or you do on the social media will return some kind of a data. Okay, so simply, you have been allocated some 1 GB of data on your mobile. You logged into Facebook, you've done some activity, that will definitely reduce because you have used some data from that.
Okay.
Right? So you have been generating some data from that. Okay, so for a simple example, you have your browser, okay, and you logged into Facebook, then you logged into Gmail, then you logged into some Google stuff, then you logged into some documents and you've searched for some documents, you've gone through some documents. So every activity you do is being uh, stored. I mean, it's being stored in the form of a log. If you look into the history, you can see all the list of activities you have done.
Okay.
Right? So that is the set of data which can be used for further purpose. For example, if I wanted to know what is the website you have logged in at some 7 a.m. of time, 7 a.m. or 7 p.m. time, you can just go through the log data and you can just search at 7 a.m. what is the website you have logged in. That's the data, and this is the information I got it from there. Okay. So there is so much of activity going on there in social media or in media stuff. Like coming to social media, we have got so many things. They take it YouTube, Twitter, Facebook, or anything. Okay, so all these are actually increasing this data size in the current market. They are all increasing the data size. Okay, and the final thing is the online transaction processing. We have OLTP. Okay, so OLTP is online transaction processing, which we'll discuss in further sessions. Like what are the data sets come under this OLTP. Okay, this is something related to the organizational stuff. So within your organization, so whatever the transactions you do, whatever the data transactions you do, you move some data from one location to other location. You trigger some data, you generate some data. So all these are online transaction processing related. We'll be getting to this more details on that a little later. So to conclude on this, these are the three different sources from where your data is expected to generate. Okay. And moving on further, we have an interesting slide here. This is the big data minute. Okay. The big data minute as in a minute of time, in 60 seconds of time, what is the amount of activity that is being expected to happen throughout the globe? Okay. So, for example, emails. You can see in a minute of time across the globe, there are some 168 million emails have been sent. Assumption. This is just kind of an assumption. Okay. And there are some 694 search queries are done on Google. Okay, if you can just easily understand, we have some 370,000 voice calls on Skype. Okay, so that's a very big number. If you see, some 600 plus new videos are being uploaded to YouTube. That means roughly the video, if you just imagine a good quality video, something around is ranging from somewhere around 50 to 60 MB or 50 to some 100 MB of data of size. I'm sorry. A good quality YouTube video will have some 50 to 100 MB of size. So in that way, I have some 600 plus new videos are getting uploaded into YouTube every minute. You can just imagine the amount of activities, activity which is going on in an hour, in a day, or in a week of time, or in a month of time, or in a year of time. This is just an assumption. It's being done in 60 seconds of time, and these are only restricting to these applications. There are some list of some only minimum number of applications which have been given: the Skype, Twitter, LinkedIn, and Google, and some email and YouTube. So there are so many applications as such. You have Facebook, you have WhatsApp. Some around 20.9 million messages are being sent on, are being exchanged on WhatsApp every minute. And so that's a large number. That's a large number. So where is this all going now? This is again coming to us. This is what we actually process. This is what we actually store. Okay. Right. Clear this point, the first point, which is all related to your storage. Okay. And the next important point of your big data is, the next important challenge I can say of your big data is the type. The type of the data is also different. Have you heard about this three types: structured, semi-structured, and unstructured?
No.
So structured is, for example, you have a data, you want to segregate it in the form of structured, semi-structured, and unstructured. Okay. It can be of three types. It can be of three types. So, for example, you know what is a table, right?
Mm-hmm.
Table name, suppose EMP. I have three columns: ID, name, and salary, and I have some 10 records. Okay. So I call it a structured data when the next value is expected. For example, I have ID, name, and salary. I have entered ID as 1. What would be the next value? That's definitely a name, right? And what would be the next value after name? It would be a salary. So again, it would be ID. Again, it would be name, and then salary, and ID, name, and salary, because I have only 3 columns in the table. What of the entries I gave, that would be, first one would be ID, second one would be name, and third one would be salary. So to be simple, to be more specific, it has some kind of a structure. That means a table, 3 columns, and some 10 rows. That's it. It doesn't increase more than that. Okay. So this is your structured data, some kind of a structured data. So all the tables All the tabular data will be your structured data. Okay. And when it comes to your semi-structures, as I've told in the previous example, so suppose you are doing some activity on your browser, you logged into Facebook, Gmail, Google, documents, and all this XYZ stuff. Okay. At the end of the day, you have gone through the history. You will have set of activities which you have done. Some kind of a log. You know what is a log? At 7 a.m. we have visited this. At 7:01 we have visited this. Okay. At 7:10 we have visited this. That means a series of activities.
Okay.
Okay. Say for suppose a black box. You know what is a black box? They use it in the flight.
Pardon?
They use it in a flight. For example, when some accident occurs, they just take the logs from the black box and they assume what kind of a failure it was. It keeps on recording the data from the pilots. Have you heard about it?
No.
So let's take a different example. Take your mobile bill. Simple thing. Take a mobile bill. So at 7 a.m. you have called so-and-so person and the bill generated. For example, it was a postpaid. You get at the end of the month, you get some list of, you get the bill with a list of activities. So at 7 a.m. you called this person, the bill was this. At 7:10 you called this person, the bill was this. So this is all set of activities which you have done. It's in the form of a log. Okay. So what your what do you call it? Telecom operator is doing is keeping a log of your activities and is calculating your bill amount. So what is that log? So this is the activity happened at 7 a.m. At 7:10 this is what happened. At 8 this was happened, and the next day this was happened. It's just a kind of a log. He's just generating the log information, right? So it need not be periodic. That means at 7 this was activity, at 7:10 this was activity, at 7:20 this was activity, and it need not be at 7:30 again. It can be some at 8 because it is you who is performing that activity. It is not periodic. Okay, it's not cyclic, I can say. There are some set of activities going on which need not be periodic. Which need not be in an order, I can say. Need not be in an order.
So is it depend on user's activity? Like,
see, that's just kind of an example, I can say. Okay, so for example, if you want to take the same example, so what you wanted to do, you got the mobile bill. Okay, so you got the mobile bill for November. Okay, November 1st to 31st of, say for example, 30th of November. Okay, so this is the data I have. What is the data? I get for each and every day. I can see some list of calls I made and what is the amount that has been charged for each and every call. Okay, so that is my raw data. So as a developer, you have been given this data. And what I'm asking is, my requirement is, I don't want the total month salary. I don't want the total month's bill. I just wanted to know the bill that is being generated only on the weekends. I wanted to know because how many calls I've made on the weekends and how many calls I've made on the weekdays. I just wanted to know that. Okay, it's not requirements will not be in that way, but I just wanted to know. If I say first of all, this is one of the requirement. Okay, so whatever the data which has been given to you is a semi-structured data, and you need to have a framework, you need to have a tool which can work on that semi-structured data and which can get you those results based on your requirement. What is that requirement? On weekdays, on weekends, and on weekdays, how much of bill amount I have generated. So whatever the tool I use SQL or I use PL SQL, any tool which I use to generate that particular requirement, to achieve that particular requirement is what your framework calls. Okay, so that is what your processing is made by. Structured data, you will have a table, whereas in semi-structured data, you have some series of records, set of tables. So this is an example for your semi-structured data.
okay.
Okay, and when it comes to your unstructured, so this doesn't have any structure. See, in semi-structured, in structured, you have a proper structure for that. You have a row, you have a column, you have, and it is in the form of an order. But whereas in semi-structured, you have some set of activities which need not be in an order. Okay, but in unstructured, nothing would be there. Because you take a video. Okay, you take an audio. These all come under your unstructured data.
Okay.
Okay, so These are the three types of data sets, and all the frameworks which I have in the current market or which I use mostly are PL/SQL or Oracle, what I've told, like these are the frameworks. They can only process structured data and semi-structured also. Some of them also process semi-structured. But coming to the unstructured data, there are not many. We have NoSQL, we have MongoDB. These are the tools which can be used to process unstructured. Okay, so this is the challenge. So I have almost all the frameworks which can handle my semi-structured and structured, but whereas coming to my unstructured data, I don't have a proper framework to handle. Moreover, the data size or the data growth is more happening in the unstructured data rather than compared to structured and semi-structured. My unstructured data is the thing which is growing a lot. As we discussed earlier, the social media stuff. You see so many people getting logged into Facebook, so many people are getting awareness on the Facebook. Say for example, you have some 10 people who have got logins in Facebook for Facebook in 10 years of time, 10 years back. Now we have got some 100 people, now we have got some 1,000 people. Tomorrow you might get another 100 people newly logging in. Right? The number of people using it are definitely increasing. That means that's where the amount of unstructured data is growing. Right? So that's my concern. My unstructured data is growing, but I do not have a proper framework to handle it. Okay, so these are the two main concerns, two main reasons of introducing a new framework. The first reason is the size of the data. Okay, the size of the data is keeping on increasing, but my frameworks are nowhere in a position to handle such large amounts of data. So I need to upgrade my framework. That's one reason. And whereas my second requirement is the unstructured. So I do not have a proper framework which can handle unstructured data effectively. That's my second requirement. So whatever the framework I design now, the new framework which we are trying to design should cope up with these two requirements. Should be able to fulfill these two requirements. Clear with this? Clear with this stuff?
Hello?
Yes, Deepika. Clear with this stuff?
Pardon?
Clear with the discussion?
Yes.
Like the two requirements?
Yes.
Right? Now, let's go to the characteristics. So what are the characteristics of my framework? What all needs to be there for my framework? The first thing is the volume. So this is one of the characteristics. So we call this as 5 V's: volume, velocity, variety, veracity, and value. Okay. So we have been talking about the frameworks which we are trying to design. That is actually the Hadoop. Okay. So these are all the conditions or the criteria which have led for the introduction of a new framework that is called as Hadoop. Okay. And that framework will have these below 5 characteristics. Should have these below 5 characteristics. Okay. The first thing is the volume. So what does this volume mean? You know what is a volume?
Volume is the amount of something, some
right. We
data.
talk in data. Amount of something, amount of data.
Yes, amount of data.
Right. So the amount of data you generate is actually called the volume. So what is expected from my framework? That means I shouldn't have any constraint on the volume. That means I should be able to store any volumes of data.
Okay.
Okay. So that's my first requirement.
Okay.
I should be able to cope up with any volumes of data, because that's the main requirement. I'm moving to this technology, to this framework. Again, if this is also having some constraint, then there is no use of moving into different framework, right? And the next thing is the velocity. Velocity, the speed, right?
Yes.
So, for example, you have a source. You know the sources. Let's finish the sources. Take YouTube.
Hello?
Yeah, YouTube, right? So that is your source. And your framework is the receiver. I mean to say, like the data is generated from there and you are trying to capture it in your database. Okay? So say for suppose the speed of the data generation is 1 MB per second. Okay?
Okay.
And your framework also should go with the speed of the data generation. There shouldn't be any lag. Okay? See, the framework speed, the source is generating the data at some 10 MB per second. The framework also should cope up with the speed of the data generation. Okay? So that's what is the velocity characteristic. There shouldn't be any lag between the source and the receiver.
Source and what?
Receiver, whatever the database you have, you're trying to store the data in your database, so it should be able to cope up with the speed.
Okay.
Okay, so what my Hadoop framework should capture the data real time. There shouldn't be any lag.
Okay.
Okay, and the third thing is the variety. So as we have discussed about the three varieties, structured, semi-structured, and unstructured. So initially when the Hadoop was designed, it was only meant for unstructured, right? Because that's one of the requirements. That's the main requirement of my introduction to Hadoop. So I have designed this Hadoop framework for basically for unstructured datasets. But later on, the thought process was, okay, so why are we having a different framework for unstructured and why are we having a different framework for structured? So why can't we handle all the varieties of data using a single framework? Okay, so that thought process has led to some of the enhancements within Hadoop, using which our Hadoop has become a complete system which can handle all the three varieties. It's not restricted to unstructured now; it can also handle structured and semi-structured also. We'll see what all the enhancements will have.
Okay.
Okay, that's all the variety. And the fourth thing is the veracity. So veracity is kind of a trustworthiness. Trustworthiness as in, so you have a framework Hadoop, so this should be trustworthy. That means you should be able to trust the framework. Whatever the output I am generating from that framework, it should be true, right? So it shouldn't generate any false results.
I didn't get it.
It shouldn't generate any false outputs. It should only give me true outputs.
Okay.
It's more or less related to your performance of the system. It should be.
Can you give me one example for veracity?
Yes. For example, the same table. I have some ID equals to 1 and ID equals to 10. I have 10 records in the table.
Okay.
Okay. And my requirement is to generate all the IDs which are greater than, also less than 5.
Mm-hmm.
That means how many values I should get? I should get values ID equals to 1, ID equals to 2, ID equals to 3, and ID equals to 4.
Yes, 4 records.
Okay. So I am using a framework called as SQL. Okay. SQL technology. Okay. I am running an SQL query there. Select star from table where ID less than 4, ID less than 5. What is my expected output? ID equals to 1, 2, 3, and 4. But first suppose I got an output y equals to 1, 2, 3, 4, 5, and 6. That means it's a false result.
Yes.
Either the query which I gave should be wrong or the processing tool is not working properly.
Okay.
So that's an example. So it shouldn't be happening that way because these are very major requirements. You shouldn't give any false outputs there. That's the veracity. And the final thing is the value. Value as in you have run the same query, select star from EMP where ID is equal to ID less than equals to 5. Okay. So whatever the outcome you get from running that query is actually the expected result, is actually the output of your process. Right? So that final output you call it as a value. Okay. So for that matter, every process should result in a final outcome and you call it as a value. Getting it?
Hello? Hello?
Yes, Deepika.
Yeah, your voice is breaking.
Is it again, I mean, just for this value section?
The value section.
Okay. So every framework every process you do using a framework should result in a final outcome. Okay, you'll be using it to generate an outcome and that final generated outcome you call it as a value. Okay, so every framework should result a final outcome, and that outcome is called as a value. Yeah.
Okay.
So these are the 5 characteristics of your framework which you are designing now. What is that? That's Hadoop. Okay. So let's get into the details. Let's get into what a framework is all about. Okay, this is your volume. A detailed discussion on what is volume, velocity, variety, veracity, and value. Okay, so these are the 5 characteristics of your Hadoop framework. Okay, so let's now move into what is Hadoop, and we'll move into a little bit of introduction. Okay, so this is related to some history. So this is being created by 2 people, Duff Cutting and Mike Afrilla, the 2 people who have actually designed Hadoop. Okay, and the name of the project is being given after his son's toy elephant. Okay, his son's toy elephant is actually called as Hadoop, and is given the same name for the project which he developed. Okay, and even the symbol, the yellow toy elephant, is also being taken from there. This is how the name and the logo has come from.
Okay.
Okay, that's just a silly reason, but that's true. Okay. Yeah. Coming to the technical details, like the definition. So this is more or less like kind of a technical slide. Maybe I would prefer we discuss this particular discussion. We discuss this particular slide once we get into the theoretical discussion. So this is something related to the distributed storage and distributed processing, more or less like a technical stuff. Okay, so the most important point in Hadoop is like we've got 2 different components, 2 main core components, Hdfs, Hadoop Distributed File System, and MapReduce. Okay, the Hdfs for storage and MapReduce for processing. So there are 2 things. First, you need to store the data, and then you need to process it. Okay, so there are 2 components which are taking care of this. Hdfs is taking care of your storage. MapReduce is taking care of your processing. So how that is being taken care, how that is being storing, and how it is being processed, everything we have kind of an architecture where we'll discuss more on that.
Okay.
Okay, so that on the theoretical stuff. And coming to the framework, we have 4 things here. We have Hadoop Common, one kind of a framework which is part of the framework, and Hadoop Distributed File System, HDFS of course, and MapReduce and Yarn. Okay, so Hadoop Common is like, for example, this MapReduce, this is all about Java programming. Okay, so not in detail, but this is, I mean to say, like Java programming is nowhere there. It is being part of Java, but now it is being overcome, or I can say it is. We have an alternative for that. So rather than writing a Java program, we have got some alternatives also, because every developer need not be a Java developer. Every developer need not be familiar with Java. So we've got alternative scripting technology also, which you can just easily learn. Okay, that's into Pig. We call it as Pig, which is an alternative for your Java MapReduce programs. So coming to the Java programming, we have the configuration files and we have the library files for each and every Java program, which will be stored in your Hadoop Common. So it is nothing else in your Hadoop Common. It is just storing the configuration and the Java library files. And coming to HDFS, Hadoop Distributed File System, you know it is all about storage, and MapReduce is all about your processing. And you have got some limitations in HDFS and MapReduce that are being overcome in Hadoop Yarn. Okay, so HDFS and MapReduce are version 1 of Hadoop, and Hadoop Yarn is the version 2, just like that.
Okay.
The latest version of Hadoop, I can say. Okay. So we'll discuss in detail the HDFS architecture, the MapReduce architecture, the Yarn architecture, and what is the functionality of that. And we also have the ecosystem. So the main system is this, HDFS and MapReduce. On top of it, we've got all these enhancements. Okay, system is one concept, HBase is one, Hive, Mahout, Pig, Ambari, Uzi, Zookeeper. So all these are the enhancements on top of your Hadoop system. So everything is meant for a purpose. Say for suppose you have Pig. So as I've discussed earlier, just a while ago, it is Java programming in MapReduce. So for a developer who is not familiar with Java, he can also go with Pig. He need not learn Java, he can go with Pig. So it does the same work. Instead of writing a Java program, you can write a pig script.
Okay.
Okay? So that's a different tool. We'll see. We'll have to see what is pig, what is Hive, what is HBase, and what is Scoop, and what is Zookeeper. Okay, so these are all different frameworks which are on top of your Hadoop system. It's kind of an enhancement. So everything is meant for a purpose. Okay. So we'll discuss about that too. And this is just a small example. We have the same slide in the theoretical discussions. Once we get into the theoretical subject, we have the same slide. We'll be discussing that. We'll be calculating this thing in the regular sessions. Okay. And coming to the big data global market, I think these slides have been taken long ago. Okay, these are the percentage of companies which have implemented big data, and these are yet to be implemented. Okay, these percentage has definitely increased. There are so many companies which have been implementing big data technology now, and it's definitely more than what it is shown here. Okay, and coming to the pay comparison, like I can say, like Hadoop big data has been leading the pay comparison, has been leading in the pay salary in the pay. Compared to all other technologies, taking VMware, SAP, or all these stuffs, Hadoop Big Data will be on top compared to all other technologies. Okay. And also coming to the employee growth, every year around 17,000 new employees are being skilled into Hadoop. Okay. So this is even more than 17,000, I can say. Okay. This is just an assumption of the number of employees that are being skilled into Hadoop every year. Okay. These are just the marketing slides, I can say. So we'll have a quick look into the...
I have one question. So when did this started, the big data concepts? So
when is it introduced, you mean to say?
Yeah.
It's been introduced in 2005.
2005, okay. But it was not, there was no opportunities, right, that time in 2005?
In 2005, I mean, like it's got introduced in 2005. By the time it reached out to market, it reached in the market, and by the time people started using it, it would be easily 5 years.
Okay.
So we hardly find a person with, at this moment, we hardly find a person with more than 7 years or 8 years, everything into Hadoop. It's very difficult to find such a person because it's being introduced in 2005. It would definitely take 2 to 3 years, 3 to 4 years to into the market.
Okay.
Right. So we'll have a look into the course outline as well. Yeah, I'm pulling all these documents from the drive. I have logged in from a different machine. So don't mind. I'll be able to share these documents anyway once we are done with the sessions, once we are concluding the regular session. So this is how we go with the course. Let's start with the introduction to Hadoop. What is Hadoop and what is the history, and how the name is given, and what are the problems with the tools, what are the problems with the existing tools, and why are we moving into Hadoop, okay, and what are the features of Hadoop, what is something different in Hadoop, why are we moving into Hadoop, and then we'll start with the hands-on as in installation of Hadoop in a machine. Okay, so Hadoop is more or less kind of a 60 to 40% of hands-on. The more you practice, the more you get familiar. There is a less amount of theoretical sessions. You need to practice. You need to write queries. You need to write scripts. You need to run the commands. More and more you run the commands. More and more you get familiar to all those commands and scripts. It will be very good. Okay. So we'll see the installation. So once we are done with the introduction to Hadoop, we'll install Hadoop in our machine, your machine. So that we can proceed with the hands-on straight away. So once we are done with the installations, when the system is set up, we'll start with the Hdfs introduction.
Shravan, excuse me, your voice is breaking now.
Sorry. I didn't face any issue. I mean, I didn't face this kind of an issue. I take almost 3 sessions every day. This is the first time. I don't know why. And this is the first evening session I have. All the sessions are in the morning. That shouldn't be the reason, right? But I don't know why this kind of problem is coming.
Your voice is like little low, and then it is a little high, like that. It's not all the time. Sometimes.
It might be because of the modulation, or I can say, but I sometimes go up and down. But it shouldn't have any a disconnect. There should be any disconnect here. I don't know. There is some network fluctuation, I believe. Okay.
Okay.
But is it fine now? Can we continue now? We just have
Yes.
some 15 to 10 minutes. That's it.
Yes. Yeah.
Yeah. So we'll start with the HDFS. We'll see architecture. We'll see the detailed discussion of what is HDFS and how the data will be stored or processed or everything. And we'll slowly move on to the hands-on of HDFS, how the data can be stored in HDFS, how it can be retrieved. We'll run some commands. Okay. And once we're done with HDFS, we'll discuss about MapReduce, how a MapReduce job works, what is actually happening when you write a program, how it is getting executed. Okay. And we'll also have some sample programs executed, and I'll be sharing the code, I'll be sharing the content, I'll help you in executing the commands, and I'll help you in executing the programs. We'll have a little bit discussion on Java, the basics of Java, and we'll start with the programming. Okay, so before we start with the programming, we'll have a discussion on Java also, basics of Java. Okay. Once we're done with MapReduce, there is something included here. There is yarn, which is included after MapReduce, which is not part of this course content, but that will be part of our discussion. Okay. So in yarn, we'll discuss about architecture and the execution flow. So what are the differences between your existing version and your yarn? So what are the limitations in your existing version and why you're moving for yarn? Okay. Then, so once we're done with the yarn discussion, we'll move with the ecosystem, starting with Scoop, Hive, Pig, and HBase. So each and every concept, we have the architecture, we have the theoretical discussion, and we have the hands-on. Okay, so we'll install Scoop, we'll go with the architecture, we'll go with the hands-on, we'll install Hive, we'll go with the architecture, we'll go with theoretical discussion and hands-on. Same thing for Pig and HBase. Okay, so all these components will have a detailed discussion, starting with installation, architecture, theoretical discussion, as well as the hands-on. Okay, so at the end of the course, we would share the content, the certification content, I can say. In case if you are also looking for any certification in Hadoop, the dump which we are going to share would be helpful for you. Okay, so this is how we go with the course, and I think I am done with my discussion. If you have any questions, we can discuss.
So currently, are you working on Hadoop now?
Yes, I am working for Hadoop.
Okay. So
where are you? Yes, I'm working for Infosys.
Infosys. Okay. 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 So so how long did you work on Hadoop?
It's been 3.5 years on Hadoop. Okay.
Okay.
And all in all, I have some close to some 5.5 years of experience. All in all, more than 5.5 years.
On Hadoop?
No. Within Hadoop, it is 3.5, and
Okay.
the overall experience would be around 5.5, 5.8, close to that.
Oh, okay. And do you provide even online support? Like if I get an opportunity in some other company, so do you give support also, like background support, like in future?
Yes, we do that as well. You may have to reach out to Jilani in case of all those stuff, because it's apart from the training. Okay, so as part of training, we cover this particular course. Okay?
Apart
So
from
yes,
I'm
apart
just
from
asking the doubts, like okay.
yeah, this is apart from training. You also have the job support or the interview support. Even you may check with Jilani in that case. Okay, but that will be provided. No issues with that.
Okay. And so how long will it take to complete the course?
Yes, so it would take around 30 to 40 sessions, I can say. I'm taking a long difference because 30 to 40, because sometimes we may have to cancel the sessions on the weekdays, because we have sessions from Monday to Saturday, Monday to Friday. Okay, on weekdays, on weekends we'll be taking an off. In case if there is a cancellation on the weekdays because of your unavailability or my unavailability, we may have to compensate that on the weekend based on your convenience again. Okay.
Okay.
So roughly it would take 30 days, 1 month. It might extend a bit, 1 week or 2, 1 week or 2, but not more than that.
Okay. So How many hours, like how many hours do you take daily?
It would be
Like
1 hour a day.
1 hour a day, okay. Okay, and practical sessions, do we have any practical sessions?
We do have practical sessions. At most, I'm trying to say that, yeah, I'm trying to stress on that. At most, 60 to 70% of our sessions would be on practical. And
Okay.
I would ask you to do that rather than me sharing the screen and me doing it and you just watching it. It's better you run the commands, and I would be dictating you the commands. I would be sharing the screen. I would be telling you the commands how to execute and how to run. You would be working on the system. That's how we can deliver. You will get a
Okay.
UI, a real-time experience on all the commands, and you'll get familiar with the framework.
Okay. Okay. Mm. So, will you provide me the your contact number so that if I have any doubts, I can reach you out?
In that case, you may check with Jilani, so he can
Okay.
put us on the conference. So at least until we get confirmed. Okay, so you may have to check with Jilani. You can reach out to Jilani, and because I
Sure.
sit in IST time anyway, so we can discuss any kind of
Okay.
thing. So you can reach out to Jilani, and they'll be able to contact me directly. Okay.
Okay. Fine. Thank you.
Any
Thank
further
you so much.
questions? Are we good to wind up?
Okay, okay, Deepika and Shravan, thanks for your time. Deepika, I'll get back to you tomorrow morning to discuss more on this, okay?
Sure, sure, Jilani. Thank you so much.
Yeah, you're welcome. Yeah,
Yeah.
Shravan, good night, Shravan. I'll update you the status by tomorrow evening, okay? Thanks, guy. Bye.
Thank you so much, Jilani.
Yeah,
Have
bye.
a nice day.
Yeah, you too,
Bye,
bye.
Thank
Deepika.
Good
you.
night.